All right, a lot of being able to understand how calculus relates to physics is understanding the vocab. Understanding what the question is asking for, clue words to look for. It's not the calculus. The act of doing the calculus, is taking the derivative and doing the math, is usually not the hard part. It's the understanding of what you need to be answering. So we need to kind of lay some groundwork in terms of vocab that you need to know so that you can do the right math based on the vocab. All right, first thing you need to know about physics is the definition of the word displacement. Okay, there's a description of what displacement means, but then there's also a formula for displacement. Right? Displacement as a definition is the difference between your starting and finishing points. Whoops. I like to think of displacement as the contrast between a track and field athlete and a cross-country athlete. Okay, a track and field athlete, especially if they're let's say they're running the 1600, okay, in track and field. Where do they do that on? They do that on the oval track, right? So for a track and field athlete, how many times around the track is a 1600? You guys know? No, 4. All right. For a track and field athlete, they've just run 1600 meters. But their displacement, because they're running in a circle, is what? Is 0. Because, well, aside from starting lanes being staggered and whatever, but the difference between where they start and they finish is typically the same. And so the poor track and field athlete has a displacement of 0, even though they're like, I just ran 1600 meters. Whereas a cross-country runner, if they have had their start and their finish and they've been out there running, those start and their finishes happen in different places because they've run a different course. And then they know, okay, I've really just run 3,000 meters. Okay, and they can feel, both athletes have worked really hard, but one athlete is a totally different displacement than another because based on where the start and finishes are. The formula for displacement is the following. F of B minus F of A. The place where you stop minus the place where you start. And that is called displacement. So that's the first thing you need to know about physics. Second thing, average rate of change. To have an average rate of change, it's going to take all of the speeds and velocities over the course of the amount of time you've gone and divide it by how long you've been out there. So the average rate of change by definition always takes the displacement and divides it by the time that you've been running. The average rate of change is the ratio between the displacement and the amount of time that's passed. So the displacement is F of B minus F of A, and then you divide that by how much time. Okay, so if a truck driver is on a long haul and their displacement is 575 miles, the difference between where they start and they stop, and it took them, 10 hours to get there, so their average rate of change is going to be their displacement of 575 divided by their time traveled, which was 10 hours. That will give you an average rate of change. We get lazy and we call that average speed. Okay, that's not really accurate. It's the average rate of change. All right, so that's your next thing in physics. So if they say find the average rate of change, you need to know what they're talking about. That's different than average velocity. All right, we got to talk about what velocity is. Then you've got the average rate of change. You have the instantaneous rate of change. That in physics is what we call velocity. So you need to very clearly know the difference between average and instantaneous, because they're going to be two different things. And of course, the formula for velocity is going to be f prime. The derivative will give you the value of the velocity. Velocity can be either positive or negative. So positives and negatives are okay. If you have negative velocity, then depending on the situation, that means you're either going down or you're going left. If it's a situation you're describing vertical movement, then negative velocity means you're going down. You've jumped out of an airplane and you're falling. Okay, as opposed to negative velocity, like on a horizontal plane, like you're skating backwards. That would be negative velocity. All right, so you got to know that. A similar one with a slight difference is the question of speed. Speed, by definition, is the absolute value of velocity. And so it will be the absolute value of whatever the derivative was. So that is speed. In our society, in our vernacular, when we talk about this, we usually talk about speed. We don't talk about velocity. I don't say, I drove to school today at negative 35 miles an hour. Or I drove home at negative 35 miles an hour. Okay, we don't use that kind of, even though one of them had to have been positive and either my way to school or my way home from school, if I'm going the same direction, the same route, has to be negative. Because one's considered forward and one's considered backwards. But in our vernacular, we just say, we always call it positive. And so speed is always denoted as the positive value. All right, then you've got acceleration. Oops. Acceleration, defined in physics, is the second derivative. There are some accelerations that you should have memorized. For example, the acceleration of gravity due to gravity. You should know that number. Okay, it's negative 9.8 or negative 32. Why is acceleration due to gravity negative? Because it pulls things down. What if it was a magnet that repelled you? Okay, what if gravity was a magnet that repelled you? Then you'd have positive, but that means we'd all be like bouncing off the earth. Okay, and then one we don't talk about super often, but it's called literally jerk. And that is the derivative of the acceleration. That is F triple prime. Believe me, you felt jerk. If you've ever been in a car accident, if you've ever been rear-ended, you felt jerk. If you've ever ridden a roller coaster that takes off really quickly and you're like pressed back into your seat, that's jerk. Okay, you feel it. You feel jerk because of the acceleration. The acceleration is accelerating, therefore you feel jerk. Okay, when the acceleration is accelerating, that's when you're going to feel that. So that's just vocab that you need to understand. Okay, so now the application of physical situations. So we're just going to take something simple, like something that's been thrown into the air. Okay, that's a real simple physics example. An object being thrown, but that's being pulled back down by gravity. All right, so we are going to have a projectile or an object. Okay, so an object is thrown according to h of x being equal to negative 16t squared plus 160t. Everything you're going to be asked about this object can be answered without a calculator using calculus and physics. So The easy way would be to draw a picture of this and then answer all the questions off the picture, off the graph. Okay, this is clearly going to be a parabola. Parabola will clearly be upside down because it has a negative leading coefficient. So we should have that idea in our head, but we're not going to use our calculators to answer the questions. We're going to use calculus and physics to answer the questions. All right, so question A, find the maximum height. Give me another way to state that, give that statement using a different vocabulary word. Find the what? The vertex. Okay, the maximum height is also occurring at the vertex. And like I was talking about with Cassidy earlier, from a physics standpoint, what happens is happening to the object at its vertex. All right, so let's think about this from a physics standpoint. From a physics standpoint, okay, this object goes up and down like this. Physically, what's happening at the vertex? Okay, for one instantaneous moment, this thing stops in midair. It stops going up so that it can prepare to do what? Go down. All right, so you've watched cartoons where, you know, the coyote goes off the edge of the cliff and he sort of hangs there suspended before he finally goes down. Okay, that's exaggerated physics. It's not really happening. From a physical standpoint, it is motionless. Okay, motion is velocity. So for a moment, for an instant, this has zero velocity. From a calculus standpoint, if this has zero velocity, what else does it have zero of from a calculus standpoint? Zero derivative. Okay, so from a physics standpoint, it has zero velocity. So that's important to understand. Is at that moment, physics means we have zero velocity. In calculus, that means we have zero derivative. And so we're going to approach this from a calculus standpoint. We're going to find the derivative, set it equal to 0, and solve. So I'm going to take h prime, which is negative 32t plus 160. So this is the same type of question you were working with. Set that equal to 0, and we find out that t is 5. So that is the whole point of understanding the connection between physics and calculus so that you can do the math and come up with what the maximum height will be. Now this is not the maximum height. This is the time at which the maximum height is occurring. So how do you figure out the maximum height? Okay, you go back and we're going to find h of 5 itself. So negative 16 times 5 squared plus 160 times 5. And you'll actually figure out that that is 400. Does anybody remember from HAM or any of the other classes, there was a little formula that we taught you about how to find the vertex of something? Ooh, negative b over 2a. Do you ever wonder where that came from? Like, hey, the formula is, the vertex is always negative b over 2a. Did anybody actually use that on their homework? Okay, do you know why it's negative b over 2a? It's so cool. All right, because for any parabola, here's the formula. ax squared plus bx plus c. That's any parabola, so we'll call that f of x. At every parabola, the maximum has a zero derivative. So what would happen if we found the derivative of it with letters? So what's the derivative of ax squared? 2ax. What's the derivative of bx? What's the derivative of c? And so then that's going to be equal to f prime. And if I want to know when that's equal to 0, which is when it's hovering with zero derivative at the top, I set this equal to 0. And I solve. 2ax equals negative b. So x is negative b over 2a. That's where that comes from. Okay? Every parabola has its vertex at negative b over 2a. And that can be proved using calculus and using derivatives. Okay, let's do part B. How fast is the object moving when it impacts the ground? How fast is the object moving when it impacts the ground? So let's go back to picturing this thing. Here's my, okay, and it's going to hit the ground right there. So last time, from a physics standpoint, the velocity was 0 because I was hovering at the top. This time, from a physics standpoint, what is 0? What's 0 when I've now hit the ground? Height. Okay, when I'm on the ground, I have no height. And so something's always 0 from a physics standpoint. So from a mathematical standpoint, that means the original equation is 0. So that's going to be negative 16t squared plus 160t, and that will be set equal to 0. So from a physics standpoint, something is always 0. Either it has 0 velocity, or it has 0 height, or maybe it'll have 0 acceleration. So this has 0 height, so I'm going to substitute, and I get to factor out negative 16t, which is going to leave me with t minus 10. And so t turns out to be 0 and 10. So why did I get 2 answers? It's on the ground how many times? Twice. It's on the ground at the beginning, and it's at the ground, on the ground at the end. So what's its displacement? Okay. What's its displacement? What's the difference between its starting position and its ending position? That's height. Starting height and its ending height. 0. Displacement is 0. I don't mean the displacement in the amount of time that's gone on. Displacement is its difference between its starting height and its ending height. Its displacement is 0, because displacement would be h of 10 minus h of 0, and that's all 0, so the displacement is 0. All right, we're going to be focusing on the 10 right now, because that's when it's coming back to the ground. So here's where time is 10, and here's where time is 0. My question is, how fast? So when it says how fast, what is that phraseology asking me to find? Velocity. So now from a mathematics standpoint, I want to answer how fast with the question of what its velocity is. So the question is, what is its velocity? So I need to find f prime again, or go back to my h prime. My h prime was negative 32, h of t, there we go, negative 32t plus 160. And so finding that at 10 would be negative 32 times 10 plus 160. That's 320 negative plus 160. So that's negative 160. What are the units on velocity? Okay, is this meters or feet? Well, you have to go back to looking at the original equation. If the original equation had a 16 in it, okay, that's half of gravity from physics. And so if the gravity is being measured by 32, then this whole problem is being measured in what unit? This is in feet. Okay, gravity is being measured in 32 feet per second squared for gravity. And so this is going to be 160 feet per second, not per second squared, that's an acceleration, feet per second. Now that's the velocity. The fact that it's negative means that the object is doing what? Going down. Negative means that because it has negative velocity, the object is going down. It is different than if I would say, what is the speed? And so then if you're asked, what is the speed? Okay, the speed is the absolute value of whatever you got, and so the speed is positive 160 feet per second. Okay, question C. Yes. All right, our next question. Is the object speeding up? at time equals 3. This is a tricky question just from an English standpoint. The phrase speeding up has nothing to do with speed. Okay, this is an English phrase. What's the opposite of speeding up in English? Slowing down in English. So if English is not your first language, just know that when we're talking about speeding up or slowing down, it actually has nothing to do with speed. The question of whether something is speeding up or slowing down deals with the comparison between velocity and acceleration. You have to check both. You have to check the velocity, you have to check the acceleration and see what those values both are. So we're going to do that to answer this question. So we need to check the velocity. So we need to check the velocity of h prime at 3. Now we already found the derivative. So this is going to be negative 32 times 3 plus 160. So negative 96 plus 160, so 64. That's the velocity, measured in what unit again? Feet per second. Now because this velocity is positive, what does that tell you that the object is doing at this moment in time? Going up. All right, now let's check the acceleration. H double prime at 3. Well, we haven't found the acceleration yet. Acceleration would be the second derivative. So based on what your first derivative is, what did the second derivative turn out to be? Negative 32. That's it. It's a constant. Which should make sense because the only acceleration is due to what physical force? Gravity. That's the only acceleration here. And acceleration is measured in what unit? Feet per second squared. To answer the question, you look at those two things. It has positive velocity with negative acceleration. So the object is trying to go up with positive velocity, but acceleration is pulling what direction? Down. And so is this thing gaining speed or losing speed? It's losing speed because the acceleration and the velocity are working against each other. Okay, because the velocity and acceleration are both opposite, then this thing is not speeding up. It is going up, but that is different than it's speeding up. It is going up, but it is slowing down. Okay, it is going up, its direction is facing upwards, but it is slowing down as it's happening. All right, so then you would say, is the object speeding up? No. Something like, although the object has positive velocity, okay, although the object has positive velocity, the negative acceleration causes it to slow down. All right, that's what's happening at time 3. The object has positive velocity, but it has negative acceleration. If you're into vectors and things like that, these are opposite vectors. They're working against each other, which causes it to slow down. All right, so a follow-up question would be, is the object speeding up at time 3, or excuse me, at time 6? So you're going to do the same thing. You're going to compare the velocity and the acceleration at time 6 so that you can answer that question. And so we want to figure out what the velocity is at time 6. We want to figure out what the acceleration is at time 6 and see how we would answer that. So the velocity will be h prime at 6. The acceleration will be h double prime at 6. H prime at 6 is negative 32 times 6 plus 160. What is that, 182? 192. Negative 192 plus 160. Negative 192 plus 160 is negative 20. No, negative 32. And then h double prime is still the constant, negative 32. So they're both negative 32. All right, is the object speeding up at time 6? Well, the velocity is negative, which means it's going what direction? The acceleration is negative, which means it's pulling it down. So is it speeding up? Okay, and the answer is, again, yes, it's speeding up because the vectors, because the velocity and acceleration have the same sign. Since the velocity and the acceleration are both negative now, they work together to cause the object to speed up. And so the answer is yes. Because the velocity and acceleration have the same sign. They're both negative. That's a commonly missed question because students who aren't trained to think that way will only ever check the velocity. Is it speeding up? They check the velocity, they're like, oh, the velocity is negative. No, it's not speeding up. That's not what speeding up means. Speeding up is not the same as speed. Speeding up is the comparison of velocity and acceleration to each other. All right, how are we doing? Any questions so far? Yeah.
So if they were both positive, they would also be...
Yes, yes. The answer to the question of whether it's speeding up is yes if the velocity and acceleration have the same sign, regardless of what sign that is. If they're both positive, then yes, it's speeding up. If they're both negative, so like a rocket being launched, that velocity and the acceleration because of the explosion are both positive, and so that's going to be speeding up to the point where it speeds up fast enough to escape our gravity. But if that rocket explosion was not enough, then eventually that rocket will just fall right back down to Earth, which happened many, many times when they were first trying to launch rockets. They just did not have enough acceleration to overcome gravity, and the thing would just come imploding back to Earth. All right, last question. Find the speed. Okay, notice the change in question. It doesn't say velocity, it does say speed. Find the speed at a height of 256. Well, how many times does this have a height of 256? We remember what the maximum height was? That was our first question. It was 400, right? The maximum height was 400. So how often does this have a height of 256? Twice. All right, so we'll say it's about right there, 256. So from a mathematics standpoint, how do I solve that? Do I need a derivative? No, it's just a height. Height is the original equation, negative 16t squared plus 160t equals 256. What should I do with that 256? Okay, I need to pull it over to the other side because whenever you're solving a quadratic equation, you need to set it equal to 0. That can be factored by taking the negative 16 out because the entire equation has 16 in it. So this factors perfectly. A negative 16 on the outside and t squared minus 10t plus 16 on the inside, which further factors very nicely into t minus 8, t minus 2. So the two times are 2 and 8. That doesn't answer the question though. That's when I get to a height of 256, but the question is find the speed. So what do I have to find first before I can find the speed? Find the velocity, and then speed is just going to be the absolute value of that. So let's find the velocity first. So the velocity at h prime of 2 is going to be negative 16 times 2 plus 160. That's negative 32 plus 160. What'd I do? Oh, yeah. All right, now that we got that fixed. All right, so that's going to be 96, and it's going to be measured in feet per second. So I don't need absolute value because it's already positive. So I know that the speed going up at time 2 when it hits that height is 96. At h prime of 8, because of the symmetry, negative 32 times 8 plus 160, that turns out to be negative 96. And so that I will need the absolute value around, and so it will also have a speed of 96 feet per second. They have different velocities, but they have the same speed.